Let's get back to the second part of this data analysis using pandas. And I'll first go through some basic ideas about pandas, and then we'll go into a hands-on session with pandas. So pandas is a highly optimized Python software to manipulate your data. You can consider it's a command line tool like Excel. So it can do almost all the things Excel can do, and it can do things in a very efficient way. And you can batch process your files quickly. You can write code, integrate with other Python libraries and tools to deal with your datasets. It can read and write data in memory into data structures, predefined data structures, and make it very efficient to go from one format to another format, go from save and read data from different formats. It's capable of reshaping and updating the datasets, and we'll see some examples later on. And also it's using so-called label-based slicing. And also it has all the indexing and subsetting the large datasets with the labels, and we'll show some examples later on as well. And it's capable of doing data filtration and a query. And it can do something like SQL language, but SQL here, structured query language used in databases. But pandas can do this in a more, I think, an intuitive way. You don't need to learn SQL to do any query here in pandas, and you just need to understand what you need for your data, and you put in the right query information and filtration data filtration information. Pandas will return the right dataset, sub-dataset for you. So all the tools provided by pandas and Matplotlib make it easy for you to explore your data and make it your life as a data science much easier than before pandas was there. And also it's free and open source, so feel free to leverage the tools available to you and try to do something more interesting. So pandas is very suited for many different kinds of data, and especially suitable for dealing with tabular data. It's just like SQL table or Excel spreadsheets that can do for you, and you can use pandas to do everything about your tabular dataset, extract the data, find the right subset, update it, sort it, and pivot it, and doing anything about tabular. It gives you all the tools you needed. So it's capable of doing ordered and unordered time series data, and pandas has a very powerful time sequence handling tools to recognize different timestamp formats, can help easily with the time sequence data. And we'll see some examples later as well. So it can handle arbitrary matrix data with row and column labels, and it can read in directly into tabular format and make it easy to explore and analyze. And it's capable of open many other forms of observational statistical data sets, as long as it's in certain format. Don't need to be very well organized. You can always doing hierarchical reformatting. In a sense, you can do higher level formatting of your data into multiple groups, and then on each group you can dealing with more detailed formats by looking into the separation and organization of the data through some user-defined separators, and make it kind of easy for you to read the data from different formats and write data into multiple formats. So pandas has two data structures that are descriptive and optimized for data within different dimensions. The first one is just simple series. You can consider a series as a 1D labeled array, nothing more, nothing less. It's just 1D labeled array. And you can consider it as a dictionary in some sense. You use a label as a key and the 1D array as values. Another one is a data frame. It's a general 2D labeled size mutable. You can change the size of it. Tabular structure with potentially heterogeneous typed columns. So you can change modifying and updating and deleting and doing all the things you need about data frame. So you can consider data frame it's like a table in the Excel file. In Excel file, you can have multiple tables. And in data frame, it's just one big table with all the functionalities built into this data frame object. and you can use that to manipulate your data frame. So series is a one-dimensional labeled array, as I mentioned previously, and the access labels are collectively referred to as an index. And this index could be letters, strings, timestamps, or just simple values. And to create a series from numbers, a list of numbers, you can simply call the pandas series, and then you can set the index explicitly like the one showing at the top of this box. And then you can create the values as random numbers, and then your indices will be A, B, C, D, E, etc. And then you can directly convert series from dictionaries or simply JSON files. You can read in and save that into 1D series. Of course, your JSON file needed to be 1D, otherwise you'll be getting into data frame or even complicated structures. But for 1D JSON file, I'm thinking 1D is you have a key pair of values like the one showing in the input cell 7. You have a D defined to be a dictionary with a B is 1, A is 0, C is 2. And then when you save that to convert that into a pandas series, it will be pandas series with A, B, C, and with A pointed to 0, B pointed to 1, C pointed to 2. So that's a series in pandas. It's just a more flexible version of dictionary. You can consider that way. Then data frame is one of the key concepts in pandas. You cannot understand pandas without understand fully what a data frame is. As I mentioned a couple times already, data frame is just two-dimensional, mutable, and data structure. It's a tabular data structure. You can imagine it as a big table in your Excel file. And instead of using mouse to click rows and columns, select a certain item, select certain cells, etc. in your Excel application, you use functions to deal with that for you. Functions more or less like sorting, choose, selection, and updating, all those kind of functions. The primary pandas data structure is the data frame. So if you really want to understand how pandas work, you need to get yourself familiar with the data frame at least. So there is a pandas cheat sheet about all the functionalities about data frames. And we are not going into the details, but I'll ask you all just to download it and then look into it. It's use it as a reference. Whenever you need something, you can probably go up there to look for. Or you can directly use online help functions using help, parentheses. Inside you can put a pandas function name there. It will give you some online help. Or you can directly refer to some online reference site. So to carry out data analysis, especially exploratory data analysis, we need to go back to review what we talked about the basics of data science itself. To get started with the data science project, you need to first get started to understand the problem first, and to understand if the project given to you is really a data analysis project or it's just something else. So when someone gives you a data set, and they need to ask you to do something about the data set anyway, if you are not even asked to carry out some very basic summarization of the data, you are not doing any data science project. You are simply describing the data in certain ways, and it's more or less like descriptive. You don't need to do numerical crunchings, do any computations to analyze the data in any way. You just need to say, hey, this is a data, I got it from somewhere, it's generated from somewhere else. It's more or less like a metadata for the data set you are dealing with. That's descriptive data science project, probably not data analysis. And then if you need to do some summarization of the data set you have, for example, you need to report to your boss what the range of data sets are, what's the mean value, what's the distribution pattern of the data, etc. You needed to carry out so-called exploratory data analysis. That's exactly what we will be focusing on today. So we are not going to build up any models or carry out any inference or predictive analysis. And we are not trying to do any more along that line. All we need to do for this descriptive data analysis is to figure out some very high-level description patterns for the dataset. We don't want to go into the fine structure of the data distribution. we need to have a rough idea about how the data is distributed. What's the big pattern, high-level pattern of the data set we are dealing with. That's more than sufficient for us to do some descriptive data analysis.